These sun rays shining through clouds were captured by Curiosity rover on Mars. It was the first time that sun rays, also known as crepuscular rays, have been viewed so clearly on Mars. Crepuscular is taken from the Latin word for twilight, as these rays appear near sunrise or sunset. The wind-sharpened rocks seen here are called ventifacts and almost look like the back of an alligator because of their scaly appearance. Rocks like these are responsible for chewing up Mars rover's wheels and has led rover engineers to find ways to slow wheel wear, including a traction control algorithm. They also plan rover routes that avoid driving over such rocks, including these latest ventifacts, which are made of sandstone, the hardest type of rock rovers have encountered on Mars. This video taken by Ingenuity helicopter during its flight using its navigation camera shows the surface features of Mars below. In flight, the blades of Ingenuity spin at 2,537 revolutions per minute. A raised segment of Jezero Crater's rim called Cape Tribulation is seen in this image. This view looks back at the southern end of the hill from about 2 football fields distance away. Wheel tracks can also be seen in this view that shows the rover's route as it descended and departed Cape Tribulation. These rocks show an example of cross-bedding that results from water passing over a loose bed of sediment. The cross-bedding, evident as layers at angles to each other, reflects formation and passage of waves of sand one on top of the other. These are known as ripples or dunes. The direction of migration of these small ripples and dunes are toward the southeast, which is toward Mount Sharp, away from the area where Curiosity rover has found evidence of delta deposits where a stream entered a lake. The directional flows recorded in the sediments are interpreted to have formed by currents moving down the deltas and into deeper lake water. This image of an asteroid was taken from the surface of Mars by Curiosity rover. The night sky image includes 2 asteroids, Ceres and Vesta, stars, and one of Mars' 2 moons, Deimos, which may have been an asteroid before being captured into orbit around Mars long time ago. Ceres, with a diameter of about 590 miles, is the largest object in the asteroid belt, large enough to be classified as a dwarf planet. Vesta is the largest object in the asteroid belt, about 350 miles wide. The 2 asteroids and 3 stars would be visible to anyone with normal eyesight standing on Mars. This is Victoria Crater, an impact crater located in the Meridiani Planum region of Mars. It is roughly 800 meters wide and 75 meters deep, and the crater retains a 5-meter raised rim consisting of 1 to 2 meters of uplifted rocks overlain by 3-meter ejecta at the rim crest. Along the edges of the crater are many outcrops within recessed alcoves and promontories. This image of Victoria Crater taken by HiRISE on NASA's Mars Reconnaissance Orbiter shows the degraded, scalloped rim and sand dunes in the crater interior. This large outflow channel shows many characteristic signs that massive amounts of water have flowed through this region on Mars, including the teardrop and streamlined islands. Curiosity Mars rover captured this image, which shows evidence of rock layers that built up as wind-blown sand accumulated in some areas and was scoured away in others in the ancient past. This panorama taken by Perseverance rover shows an interesting geologic unit of Jezero Crater. We can see several prominent geologic features at this site. At the top left and running about a third of the way to the center of the image is a portion of the delta front, a river delta that billions of years ago fed a lake at Jezero Crater. Below and to the right of that is a ridge. Farther to the right at the top of the image is the distant peak called Santa Cruz. Santa Cruz is geologically interesting since it has mineral signatures seen both from orbit and by the rover consistent with alteration minerals, primarily clays. Near the top at the far right is a portion of the route Perseverance took to get to this location. These small spherules on Martian surface are examples of mineral concretions which are nicknamed blueberries. They are rich in hematite and provide evidence of a watery ancient environment. The surface of Mars is littered with many regions of glacier-like landforms like the ones seen here. While surface ice deposits are mostly limited to the polar caps, patterns of slow viscous flowing exist in many non-polar regions on Mars. Streamlines that appear as linear ridges in the surface soils and rocky debris are often exposed on top of infilling deposits that coat crater and valley floors. We often see such patterns on the surfaces of Earth's icy glaciers and debris-covered rock glaciers. As ice flows downhill, rock and soil are plucked from the surrounding landscape and ferried along the flowing ice surface and within the icy subsurface. While this process is gradual, taking thousands of years or longer, it creates a network of linear patterns that reveal the history of ice flow. Later and under warmer conditions, the ice may be lost through melting or sublimation. Rock and minerals concentrated in these long ridges are then left behind, draped over the pre-existing landscape. Curiosity Mars rover took this image while looking back down at Marker Band Valley after climbing a very steep slope. The 23-degree slope also had slippery sand and wheel-sized boulders, which made this a very tough climb for the rover. This view shows an outcrop with finely layered rocks within the Murray Buttes region on lower Mount Sharp. The buttes and mesas rising above the surface in this area are eroded remnants of ancient sandstone that originated when winds deposited sand after lower Mount Sharp had formed. The layering within the sandstone is called cross-bedding and indicates that the sandstone was deposited by wind as migrating sand dunes. Curiosity Mars rover took these images of clouds just after sunset on Mars. These twilight clouds are made of water ice. Ice crystals reflect the setting sun, which allow the details in each cloud to be seen more easily. Perseverance Mars rover captured this image of Santa Cruz, a hill that was about 1.5 miles away from the rover. The entire scene is inside of Mars's Jezero Crater, and the crater's rim can be seen on the horizon line beyond the hill. This close-up of a rock target was captured by the SuperCam instrument on Perseverance Mars rover. The image shows a rock layer made up of millimeter-sized gray angular grains or crystals that are tightly packed. The composition of the rock target was also investigated with SuperCam's rock vaporizing laser and spectrometer, along with Mastcam Z camera system. Using these instruments, scientists can study the chemical composition of rocks from a distance. Analysis of the rock showed that it was rich in the mineral olivine. Scientists are still unsure if this is an igneous or volcanic rock or consists of fine sedimentary grains of igneous material that were cemented together in a watery environment. Sedimentary layers on a cliff are displayed in this image captured by Perseverance rover. Cliffs like these may have been created as sediment built up here in an ancient river or delta. The rippled surface of a high Martian sand dune fills this view. This site is part of the Bagnard Dunes field along the northwestern flank of Mount Sharp. The dunes are active and migrate up to about 1 yard or a meter per year. This image shows Ingenuity helicopter at a location named Valiner Hills. You can see Ingenuity sitting just left of center, a speck-like figure amid a field of sand ripples. Ingenuity damaged its rotor blades during landing on its 72nd and final flight on January 18, 2024. The image was captured from about 415 meters away by the Perseverance rover.